Okay, so today we're going to finish up graphing absolute value functions. We're on page 47 of your notebook. So you've got another foldable, or you're writing on a piece of paper, whatever. Here's your foldable. So we're going to graph them. Today the difference is going to be we're going to have a changed A value, okay? So let's start with number 1. First, we're still going to identify A and our vertex. So A is the number in front of the absolute value. It is now -2. So we have a different A value. All right, next we have the vertex. The vertex, remember, is H and K. Well, my problem with our vertex being H and K is that I don't have any numbers. I don't have a number here. I don't have a number here. If I don't have any, my vertex is 0, 0. So now I'm going to graph. I'm going to put a point on 0, 0. This is like slope, remember? So it's down 2 over 1. Down 2 over 1, down 2 over 1. Same thing, I'm going to go back to the vertex and do the same thing on the other side so that I have a V. Yes, it's going to be upside down this time. And we're going to fill out the rest of this information. Okay, the x-intercept, where does it cross the x-axis? This one only has one x-intercept, and that is at 0, 0. Okay, the y-intercept, remember, is where it crosses the y-axis. Again, it only has one, and that's at 0, 0. It only ever has one y-intercept. And it always has a y-intercept. It doesn't always have an x-intercept. All right, in behavior, then domain and range. When x approaches negative infinity over here on the left, y is going towards negative infinity. Okay. And on the right, when x goes towards infinity, y goes towards negative infinity. So now that it's pointing down this time, we are going towards the negatives. If a is negative, your end behavior is negative infinity for the y's. Just like yesterday, if a was positive and they were all 1, it was all positive infinity. Domain is still all real numbers because it continues in both directions. However, range. The y values start at 0, and they are the values that are smaller than 0. So it's less than or equal to 0. Number 2. A is 1/4. The vertex, there's no number inside, no number outside, so it's 0, 0. Put a point on 0, 0, up 1 over 4, and I can't do that more than once. Up 1 over 4. Okay, x-intercept is 0, 0. The y-intercept is also 0, 0. In behavior, remember, I could look at A and say, well, since it's positive, that tells me what it is. That only works for absolute values. But as it approaches the negative side here, negative infinity, y is going up, so it's positive infinity. And on the right side, it's also positive infinity. Okay, domain and range. The domain is all reals. The range is the y values that are greater than or equal to 0. It's greater than or equal to because it's pointing upwards. It's down if it's less than or equal to, or it's less than or equal to if it's down. All right, open that up, and I want you to do 3 and 4. Okay. Number 3. A is -1/2. The vertex is 0, 0. Put a point on 0, 0. Go down 1 over 2 until you run out of room. Then go back to the vertex and do the connect. The x-intercept, where it crosses the x-axis, and that is 0, 0. The y-intercept is where it crosses the y-axis. That's also 0, 0. The end behavior. When x approaches negative infinity, y approaches negative infinity. When x approaches positive infinity, y approaches negative infinity. Domain is still all real numbers. We eventually will have some that domain is not all real numbers. And range is y is less than or equal to 0. Number 4. Number 4, A is 4. The vertex, we finally have one now, is opposite, so negative 2, and the same, negative 1. So negative 2, negative 1, up 4. 1, 2, 3, 4 over 1. Go back to the vertex, up 1, 2, 3, 4 over 1. All right, now we finally have some intercepts other than the origin. Now, we actually, remember how when we had lines, we would have to guess and see what really works out, what it really is? We can't solve these yet. We won't solve these until after Christmas. So we are going to have to kind of guess where they are. So the x-intercept for this one is between negative 1 and negative 2. So we're going to say negative 1.5, comma 0. Okay, and then the other one is between negative 2 and negative 3. So let's say negative 2.5, comma 0. It's these 2 points right here. Now the y-intercept, we actually can solve that one. We make x 0. So you have 4 times 2 minus 1. So we'll do that right here, the y-intercept. We put a 0 here, which leaves 4, absolute value of 0 plus 2 minus 1. So 4, absolute value of 2 minus 1. And the absolute value of 2 is 2. So 4 times 2 minus 1. 4 times 2 is 8 minus 1. So that's 7. So that is 0, 7. Which it makes sense up there that it was 7. Sometimes it'll hit the graph exactly. You won't have to solve. We don't know how to solve for x-intercepts yet. That's going to happen next semester. All right, in behavior. When x approaches negative infinity, y approaches positive infinity. When x approaches infinity, y also approaches positive infinity. Domain is all real numbers, and range is y is greater than or equal to negative 1. Remember, it comes from here, or I can look and see where did it start on this y-axis, all the values above. All right, 5 through 8, we're going to do what we did yesterday where we write equations. I'm going to fold this over so you can see what we're looking for. We need to find the vertex and A like we did yesterday. A, we're going to go up 2 over 1. So A is 2 over 1, which is just 2. Might have to simplify, you never know. The vertex is 0, 0. So, and I should have highlighted this and I didn't. Okay. So y equals A, which is 2, absolute value of x minus h. H is 0, so we're just going to close the absolute value and not put 0. plus k. K is 0, so we're not going to put that either. If it is 0, 0, we're going to put a and then leave it alone. Let's do number 6. We went down 1 and over 1, 2, 3, 4. So down 1, negative 1 over 4. The vertex is at 0, 0. So this is A. So y equals negative 1/4, absolute value of x, 0, so we close it, plus 0, we don't put that. I want you to pause the video and do 7 and 8. Alright, 7. A down 2 over 3. So A equals negative 2/3. The vertex is 0, 0. So y equals negative 2/3. Absolute value of x, it's 0, so close, plus 0, we don't put that. Alright, and then number 8. Down 1 over 1. So A equals negative 1 over 1, which is just negative 1. The vertex is negative 2, comma 1. So y equals negative 1, absolute value. Notice I make that very big so it doesn't look like a 1. X, we have minus 2, so we put the opposite, plus 2. Close it, plus 1. You sometimes will also just see y equals negative, absolute value, x plus 2, plus 1. They're the same. So if you don't put the 1, that's fine. Either one is correct. All right, we are going to glue this in on page 47. That was kind of strange down there. Okay, there's your title. It's on 47. That's all. We'll talk about solving absolute value next semester.